Hi friends, I'm Yugen. Welcome to my YouTube channel Interesting Quantum. In this video, we are going to see some basic concepts in statistics through some examples. Here is a distribution in which number of photons are distributed over different states. Number of photons are denoted by J and number of states are denoted by N of J or Nj. So this states that there is one state in which there are 14 photons, there is another state in which there are 15 photons, there are three states in which there are 16 photons in each state, and so on. The name of states are given in the bracket and the outside quantity is number of states. So the total number of states are 14 and total number of photons are 294, which are distributed over these 14 number of states. Now if we have to calculate probability of finding number of photons in some states or state in number of photons, so we will see through example. So first example is we have to find the probability of finding a photon in K state. From table, it is clear that there are 16 photons in K state and there are total 294 photons. So the probability is 16 over 294. Now we will see another example. The probability of finding a state in which there are 22 photons. From the table, it is clear that there are only two states P and D in which there are 22 photons and we have 14 number of states in total. So the probability is 2 over 14. Now we will see the most probable value. It is the value which have highest probability in the distribution. In this case, 5 number of states and 25 photons are most probable value. So if I have to find number of photons in a particular state, so the most probable value is 25 because there are 5 states in which I can get 25. So the probability of finding 25 photons is larger. So this is most probable value of distribution. Now let us see what is mean or average. So as we can see, there are total number of 14 states and 294 photons. So let us consider f of j is any quantity and the mean of that quantity f of j is given by summation of f of j into nj divided by summation of nj, or simply if we have to calculate mean of j, it is given by mean j is equal to summation of j into nj divided by summation of nj. In this case, it is 294 divided by 14, it is equal to 21. This means there are 22 photons distributed over every state. At quantum level, we use this mean value, or we can call this mean value as expectation value or expected value. So this means at quantum level, if we have to measure one physical parameter only once and the value is mean value or expectation value. So this is because in quantum level we are not going to calculate physical parameter for a single electron or single photon or any single particle. We calculate the property of bulk. That's why at quantum level the mean is equal to most probable value. Now here is another example. There are two distributions given in the same graph. At right, one is different, and left one is different. But in both cases, total number of particles are 6, and the x-axis gives the name of the state, and y-axis gives number of particles in that state. In both cases, number of particles are 6. Mean and most probable value is also same in both cases, and that is 4. But still you can see the distribution is different, or we can say the spread of distribution is different. So to differentiate, we will calculate some property called variance, but before that we will see what is error or deviation. So delta z is deviation and is given by j minus mean j. So the mean of delta j, that is error or deviation, is given by summation of j minus mean j into pj, that is probability. If we solve this for both the distributions, we get the 0. This is because the sign of delta j is positive for some value and negative for some value, so the addition becomes 0. So to avoid this, we calculate variance. It is the square of error, and then we calculate its mean. It is denoted by sigma square and given by mean of square of delta j. And if we solve, we get it as mean of j square minus square of mean j. So this quantity, variance, or its square root, called as standard deviation, gives us the spread of distribution. If the quantity is 0, that is variance is 0, then there is no spread at all in the distribution. This is possible only when the mean of j square and square of mean j are equal, and usually they are not equal. They are equal only if the distribution is concentrated for a same value, or we can say the value of nj is constant for every j. So enough for this video. Thank you for watching, and in the next video we will talk some about wave function, which is the basic to learn quantum mechanics.